Hey guys, welcome back to the GSP YouTube channel, and I'm going to do something just a little bit more personal today. As I've kind of alluded to, got a new camera, and so I'm going to do kind of a side-by-side thing here. I've got my laptop in front of me, and I got the camera facing right towards my person, so I'll be able to talk to it a little bit more and use my hands because, you know, it makes things a little easier to talk about. That way you're not just staring at a software screen. You actually got something a little bit better to look at because, you know, all of this. So this is something that I think is going to be really quite helpful for a lot of people. Let's convert a E85 tune to gas or gas to E85, and I think what I'm going to do, I'll start with a gas to E85 and then we'll convert it back. I know you typically don't go that direction, but what I think that might be helpful for is the situations where you've tried E85 and it went well for you, and so the next step is to get a flex sensor, right? So you add the flex sensor, but then me personally, I like to use gasoline as my base and then add fuel for flex content. And you can do it the other way around. You can subtract fuel for lower ethanol, or you can add fuel for higher ethanol, depending on where you're coming from. It's purely, honestly, it's just preference. The reason that I like to go from gas scale is because if you treat it like gas is the primary fuel, then you end up in a situation where you're always adding fuel for ethanol content. And you don't have to do any weird subtractions and division. Multiplication, in my mind, for whatever reason, just seems to work a little bit better. So I always know that we're going to add fuel for an increase in ethanol content. So let's just go ahead and take a dive into this. First things first, we got to go into the system ICF and swap this thing over to E85. And this is on a Terminator X ECU, so I'm doing this in the Terminator X software. When you swap to E85, there's a couple things that happen, but the primary one, and really the one that you're going to be accounting for, is the stoichiometric air-fuel ratio value is swapped from 14.7 or 14.68 down to 9.8, which is the stoic AFR for E85. And when that happens, you got to understand that that's the stoic value for 85% ethanol content. So if you got E60 in the tank, it's going to be just a little bit different. It's not a huge deal, but that's kind of where your flex comes into play. If you're dealing with a car, say it's a race car, and all you're putting in it is like race fuel E90 or race fuel E85, the higher quality stuff that you're not playing the pump gas games, that's a lot easier to deal with. Let's say you are playing pump gas games and you're always going to put E85 in it, excuse me. That's okay too. Don't worry about that. You should check your content doing that every now and then, especially with seasonal changes. But the reality of it is they have a minimum requirement that they have to meet. E60 or 65 is what the content is, and honestly, you're going to get the benefit of the ethanol at that level. The only difference is you're going to need to run a little more or less fuel based on ethanol content. So once we've swapped our fuel type to E85, the next major step is to reset the correct air-fuel ratio, because if you go to your fuel ICF, the target air-fuel ratio is still going to be in gas scale. When that happens, there's a couple different ways you can get there. The way that I like to do it is to just manually manipulate to the E85 AFRs that I like to see. This would be really easy if Holley would let us use Lambda, but since they don't, that's okay, and it is what it is. One thing though that's kind of convenient, so I'm going to show you guys this on the old calculator here. If you take 14.7, which is the rounded stoichiometric air-fuel ratio for gasoline, and you divide that by 9.8, you get 1.5. And it's not quite that drastic in terms of the divisor, but what it does for you is that's a 33% increase, right? What I like to use, it's a rounder number. I just put 30% in. The reason that I do 30% and not 33 point whatever percent it's supposed to actually be, if you went to 14.68 and 9.81 and we did all that stuff, is because most of the time you're usually putting in, you get to E70, E75 maybe tops. Very rarely do I ever see a true like 85% ethanol content, and that's fine. E75 is fine. But 30% is nice, because what this allows us to do is we can literally just take the whole table, and there's a couple ways you can do this. You can say I'm going to multiply it by 0.66, or in this case 0.7, 30%. And that doesn't quite get you there. It's not as far as we want to go, so I'm going to hit undo on that. You can hit offset selected, and we're going to divide by 1.5. That's pretty darn close. That's actually where we would end up being if you were going to go directly to mathematically change it. What I have found is that most of the time, the cars that I'm working on prefer to run just a touch richer AFR on E85, and I think that that's just due to the volume of fuel and the cooling effect, whatever it is with the 85, that they tend to need a little bit more. And so I'm going to clean this table up just a little bit. This is something that it's out of the Corvette. So first things first, let's just set our stoic. So we're going to go 9.8. And let's say we want to run a lambda of 0.85. So 9.8 multiplied by 0.85 gives us 8.33. So we're going to round that to 8.3. And we're going to set the power enrichment area to 8.3. So now we've got a fairly basic lambda table, or target air fuel ratio table, sorry. I wish I could do lambda. Now we got to make some adjustments for engine conditions. So I know that on decel, I'm fine if it goes a little bit lean. It's no big deal. It's not really going to be lean anyway because it's going to be on decel. So we're going to just make that, let's make that 10.2, okay? And let's say at all in my idle region, I'm going to need a little bit of help idling because this thing's got a big cam in it. We're going to go like 9. Let's go 3. And I'm going to blend this down because that's just who I am. And then I'm going to go in here and look at the fuel table and see that roughly right in the, what is that, 5,500 range, 5,000 range, I'm going to be hitting peak torque in there. And yes, something that's really actually important for me to show you guys is that as soon as I switch to E85, I do not have enough injector. Some people don't know this, but if you are showing a white cell on your fuel table with red letters, that means that you don't have enough fuel injector per the calculation to deliver the amount of fuel that you're asking for here. This works fine. This tune works fine on gasoline, but it would not be sufficient for E85. I'm running 89 to 90% injector duty cycle right now. And obviously that's not enough. If we increase by 30%, we'd be in the 120-ish range, and it's not going to work. So this is just an example. But so if I see my peak torques at roughly 52 to 55, and I know based on dyno information that it is at 52 or 55, and I'll show you how to read this a little bit later on, but we can go back in here to that target air fuel ratio, and we can make sure that that's where we're going to stay a little bit fat. And then I always come in here and we'll lean it out just a little bit. We'll do a fill row. And down here, just so this doesn't get like silly rich and then want to stumble when you first whack the throttle, if you do happen to hit it really low, you want your acceleration enrichment to take care of that, not necessarily the target air fuel ratio table. So I'll lean this back out kind of to where we're seeing right there at 85. Let's go 8.7. And then I'll feather that in up here to where we reach peak torque. So the goal here, this is what I like to do. It's for safety and power, but I will have my richest point roughly across the torque peak. So we want to reach that rich condition drive across the torque peak, and then to make peak power, it'll make a couple more upstairs if you lean it out just a little bit. Not a huge deal. If you want to run a straight tail all the way across, the engine will run fine. We're talking 1Z, 2Z stuff up there, but it is something that I do. There's nothing wrong with this at this point. You know, you can smooth and you know, feather stuff around as much as you want. This would run just fine. If you wanted to make it look pretty, you could come in here and do a fill row on this, and we can come in and do a fill column. But honestly, you're going to end up wasting fuel in here. You could definitely run stoic right there and save some fuel. We can grab this whole big region right here and hit smooth. You know, we can feather all that in as much as or as little as you want to do. But there's nothing really wrong with that. The next big thing when you're going to swap to E85 is any of your flow rate based calculations need to be updated. So what I mean by that is acceleration enrichment and startup enrichment. So first things first, let's go to acceleration. So the same thing happens here. If this worked really well for gasoline, there's a really strong chance, I'm not saying every time, but there's a really strong chance that we can just take this entire acceleration enrichment table and right click offset selected, and we're just going to simply multiply it by 1.5. We want more fuel with the 85, and bam, you got a really good starting place to work on Accel enrichment. Now, if you run into a situation where the engine wants to stumble because it's too much fuel, or a situation where the engine wants to stumble because it's not enough, you have to go in and tune this thing just like you did on gasoline. There's no real great way to do this on looking at the data logger. This is a seat of the pants kind of thing, and it's something that as far as what I do remotely, I have to take a guess at it. And if somebody has any issues with it, then we have to kind of iteratively walk through it and get it sorted out. But ultimately, you obviously don't want the engine to go completely dead rich, and you don't want the engine to go completely lean. Typically, you end up being somewhere in the 0.85 to 88 lambda range on a data logger during that event where you crack the throttle. That said, it's not always the case. Sometimes it's richer, sometimes it's leaner, sometimes it wants to see 14.7 even across the board. That typically happens more on your factory cam, that kind of application. Usually the bigger cams need just a little more help getting rolling. So there's that. Same thing applies to the map. In this case, this is an NA car, so I don't have any map enrichment set. Startup enrichment is exactly the same. If you needed more fuel or less fuel to adjust this for cranking, then you're going to run into the exact same situation with E85. If you come in here and we want to offset selected and we're going to multiply by 1.5, there you go. That should be a really good starting place in order to get you fired right up on E85. And if you run into a situation where it doesn't want to start and adding a little bit of throttle helps, then what that means is that it's rich. You added air to go with the fuel that was being injected, and that caused it to start up. If adding a little bit of throttle pedal does not help, then that usually means that it's too lean and not getting enough fuel. You're gonna have to crank something into it. All right, so those are the biggies in terms of setting your tune to E85. Just thumbing through the rest of this stuff. All that is either time or percent based, and same way with temperature enrichment. I typically don't do a big air-fuel ratio offset for temperature. This is the Holley table, and it honestly seems to work fine. I haven't had any issues with it. If you find that on E you need to make an adjustment here, there's no problem doing that, obviously. All right, so we went one way. Let's go back the other way. Let's say we have run this thing and we want to run it on the street, and it's the middle of the winter and there's not as much corn out there, and we want to have flex sensor added, and so all those things combined, we want to go back to gas, and then we'll add flex later. First things first, same situation. System ICF, gonna swap it from E85 back to gasoline. That means we change that stoichiometric air-fuel ratio. And let's say we want to go and adjust the target air-fuel ratio. Now watch this, this is kind of cool. So if we look at base fuel, you'll see that I still have got a region here based on the target air-fuel ratio that is unable to be met based on fuel injectors. So if I go in here and change this, so we want to have a higher ratio. So we're going to offset selected, and I'm not going to go through all that other stuff. I'm just going to multiply it here. So this will be times 1.5, 33% increase. Okay, so we got a little lean cruise area, and we got our rich idle, and we got a nice roughly 0.85 lambda across the torque peak. All right, awesome. Check this out. Back to base fuel, bam, it's fixed. Just like that, I have enough injector again. Obviously, this is not rocket science. It's just a matter of fuel delivery and how much you're trying to ask for. But I want to point that out. And keep in mind, too, you need larger injectors to run E85 at the same duty cycle. So if your duty cycle is already high, you're going to need to get some injectors. All right, same thing as before, just going the other direction. If we go to acceleration enrichment, I'm going to highlight the whole table. And in this case, because we're going the other way, we want that value to become lower, so we're going to divide by 1.5. Back to where it was. Startup enrichment, same exact thing. We're going to offset selected, divide by 1.5. There you go, back to where we were. And just like that, you swap from E85 to gasoline. Now, I know we didn't talk about timing, and the reason we didn't talk about timing so much is because I don't want to necessarily make you think that just because you're running E85, you need to run more timing. That's not really the case. Is it most commonly the case? Yes. There are a couple reasons why, but it's not necessarily the fact that just because you have E85 on board, you need to crank the timing up. The correct timing for your engine is going to be the amount of timing that provides maximum average cylinder pressure while the piston is on the way down, and does not provide negative work towards the piston before it is fully up to TDC and starts on its way down. And what you're saying to me right now is, well, how on earth am I going to know what timing that is? Well, sadly, there's not a great way to do it other than hopping on a dyno and not looking at absolute numbers, but looking at relative numbers. So as you increase timing, you're going to see it kind of peak, and then it'll actually start going the other way as you increase timing more. And that's for an NA application, not something that's octane limited, like a boost situation. So when that happens, you'll find that peak, and what I always run is best power minus 1 degree. That's just a little bit of a safety thing. And then make sure you have adequate offset tables for all your temperatures so that you don't ever run into a situation where it's crazy hot outside and you run the engine hot and you have high IATs, and then all of a sudden you're into a knock situation whenever you roll into the throttle. So timing is a little bit outside the scope of this video, but in terms of actually setting up and getting E85 into the tune so that you can run E85, I think we got that covered pretty well. Now, as far as what I would do when I'm starting up on an E85 tune for the first time in terms of timing, I would just go in here and just make sure that you have sufficient timing. E85 typically likes just a touch more, especially in the low VE ranges, so I would probably come in here and just make all these 20-ish. It's a little bit seat of the pants. One thing that you can do, if you have the same stretch of road and you can go the same direction on the same stretch of road, what you can do is make a pull on that stretch of road, look at your data log, and look at the RPM rate of change. So you would say, what is 3,000 to 4,000 RPM, and how long did it take me to go from 3,000 to 4,000? Then you go 4,000 to 5,000, 5,000 to 6,000. It's the same thing that a dyno is doing. It's just doing it more elegantly, and it spits you out a number as a representation of that. What you can do, though, is use that information and basically find the spot where the engine best accelerates. And where that is that timing value where it best accelerates is going to be peak timing. Okay, so that said, that's E85 conversion. If you want to say let's add a flex in here just for bonus round, you would just simply come to the IO. If you don't have that already, you would go to Toolbox, Add, Individual Config, and pick IO right here. Open that up. I already have one in here on this particular car, so it would be an input, and we're going to enable that input, and we're going to set it to frequency, and it's going to give me all kinds of errors because it goes, no, that's everything's 0 right now. When you click configure, it's going to give you, like I said, 0 here. You click use the minimum, yes, yes, yes. It's all just random numbers to get you started. Come in here and pick GM Flex Fuel, or you can do a custom frequency, but the GM Flex Fuel is probably the most common. It's so common that Holley actually has this in here. At that point, you're basically done. It's got all of this presettings that are canned in here. The only thing left that you have to do is just go to the pin map where it says flex here, assign that to an input, and then that input wire needs to go to your flex sensor, and also be sure that you have a pull-up resistor on that flex sensor, otherwise you're not going to see anything when you run. The sloppy harness and the current performance harness and all that stuff is going to have that built in. So flex is that simple, adding it. If you want to go ahead and add the tables, if I have enough tables left, I don't think I do in this tune. Doesn't look like it. We'll just go ahead and make one. So we'll throw this out. This is going to be flex fuel offset. Okay. And right now we're in gas. This is a gas tune. So we're going to do a fuel flow multiplier based on flex. We're not going to inhibit closed loop. We don't want to do that. Whereas this is going to be happening all the time. We're going to not have any kind of switched enables. We're not going to do anything like that. And it's very simply based on flex content from 0 to 100. We want to add 30%. So we'll put 30 in the final cell, highlight all of them, fill row values. Okay, now, it's not quite that simple. It's really close, but it's not quite that simple. The reason it's not is because everything's going to behave just a little differently. Your sensor's going to behave just a little differently, all that stuff. If you want to get your fuel trims really low, what you'll do is tune it on gas to perfection. Then add a little bit of flex fuel in there, add a little bit of E85, get your content to like 33% or something, and then adjust this value up and down in order to achieve the correct air-fuel ratio. And then add a little more flex, get it to 60. And adjust this up and down to get your corrections near 0. Add as much as you can get. We're going to adjust this to get as close as we can get. So what do? At that point, you just kind of draw a line through this thing, and you're going to end up with something that looks a little bit, that's a little trippy, like this. You got to fit all of those points. And you end up with a curve, of course. And it doesn't necessarily have to be, any kind of linear curve or anything. You can fudge this thing in here, and then let's say you get sort of close and you just want to go ahead here and hit smooth. Makes a nice shape in there, and that'll help you get your corrections just even lower. I kind of go crazy with that, trying to account for everything in the tune to get the correction as low as possible. So that said, we've been going for quite a while here, and I think that's going to make a good one. So please like, subscribe, do all the things, ring the bell, do all the things that I'm supposed to ask for on a YouTube channel. And if we can ever get to 1,000 subscribers, then I'll be able to do some live stuff. We'll get on the dyno and do some cool stuff. Until next time, I will see you guys later. Have a good one.